Okay, so we were doing the example problem connecting DeBroglie's wavelength with the photoelectric effect. And the question was, light strikes a photoemissive surface with a threshold wavelength of 720 nanometers. If the electrons emitted have a wavelength of 2.09 nanometers, what was the color of the incident light? So we had found the speed of the photoelectrons emitted using DeBroglie's wavelength, and then use that to find the kinetic energy, the maximum kinetic energy of those photoelectrons. And then we were going to the threshold frequency, and we were about to use that to find the threshold wavelength. Excuse me, they gave us the threshold wavelength, and we were about to use that to find the threshold frequency. So 2.9979 times 10 to the 8th meters per second divided by the 720 times 10 to the negative 9 meters will give us a threshold frequency of 4.16375 times 10 to the 14th hertz. So once we have that, then we can find our work function. WO equals HFO, so WO equals 6.626 to the negative 34 joule seconds, and that's going to be times the 4.16375 to the 14th hertz, and that'll give us a WO of 2.7589 times 10 to the negative 19 joules. Okay, so we have a WO, we have an EK max, and in our equation we know that EK max is equal to HF minus WO. So we can solve for our F because we know everything else. So rearranging, F is going to be equal to EK max plus WO divided by H. So, equals 5.517084 times 10 to the negative 20 joules plus 2.7589 times 10 to the negative 19 joules divided, of course, by 6.626 to the negative 34 joules seconds. When we do that, we get an F of 4.9964 to the 14th hertz. But the question wants wavelength because it asks for color, so we need to find wavelength. C equals F lambda, so lambda equals C divided by F. 2.9979 to the 8th meters per second divided by our 4.9964 to the 14th hertz gives us a lambda of, works out pretty darn close, that's almost 3, this is almost 5, works out to be pretty close to 6 times 10 to the negative 7 meters. Now the question actually asks for the color. And we can get the color off this cool little wavelength chart that just happens to be on this multiple choice sheet that I have, but that I haven't given you yet. But I'll post this chart. So if I make it bigger, it was 6 to the negative 7. So all of these are to the negative 7. So you look, where does 6 fall? Well, it falls between 5.9 and 6.5 to the negative 7. So the color would be orange. Okay, so we'll use this little chart a fair bit in this unit, and so I will post it, and I'll probably post the multiple choice sheet too, because if you're bored, you can start to work on it. By the end of the unit, we'll have done them all, but I haven't assigned any of them yet. So for practice for this evening, it will be on page 571 again. Numbers 14 to 21. Okay? And these ones maybe are a little bit tougher because there are a few more steps. They're kind of like you have to link them in. Okay? All right. Very good.